Alright, Chapter 7, Section 4 deals with properties of logarithms. So we did logarithms in the last section where we have some equation that has log base b, we can say, of x. So this would be some number, this can be some number or some variable. So these are logarithms. Our properties of logarithms are these three properties. We have the product property, quotient property, and power property. So the product property is when we have a log base b of two numbers that are being multiplied. We can split those up and expand the equation and add the two logs together. So we're expanding this and making it two separate logs and adding it. So product means multiply, and we're taking it from multiplication and putting it into addition. Quotient we know means divide. So when two logs are being divided, we can split them up and we can subtract them. So the quotient property, when two logs are divided, we're going to subtract. So dividing goes with subtraction. And then our last is the power property. So if we have some number with an exponent on it, we can just take that exponent and move it to the front of the equation. So we're taking this n and moving it to the front. So these are three properties of logarithms. Now we're going to do some examples about those. All right, our first example. So what is each expression written as a single logarithm? So we're trying to condense this. We have two logarithms here, so we're trying to condense it into one. We see that we have subtraction in here, and we know that division goes with subtraction. So what we're going to do is write log base 4. The first number, so our first log, goes on top. So 32 over 2. And the second number just goes on bottom. Now we can simplify this one step more because we know what 32 divided by 2 is. So we can say log base 4 of 16. So here we're condensing it into one, changing the subtraction into division, and then we just divide 32 divided by 2, which is 16. And this here is our final answer. We can actually simplify this one more because we know what log base 4 of 16 is. In the last section, we made this equal to x, and we said 4 to the x power is equal to 16. And we need to find out 4 raised to the what power is 16. We know 4 raised to the first power is 4. 4 raised to the second power would be 16. So 4 raised to the second power is 16. That means x is equal to 2. So this whole equation here is equal to 2. Any questions on this one? All right, let's go to the B example. So here we have 6 times log base 2 of x plus 5 times log base 2 of y. So we said that if a number is out front, we can just bring it up to be the exponent. So this is our power property. So we're going to change this to log base 2 of x to the 6th power plus log base 2 of y to the 5th power. Now we have two logs that are being added, and we know that addition goes with multiplication. So in order to combine these into one, I'm just going to multiply them together. So we have log base 2, x to the 6th power, y to the 5th power. So I get rid of this second log when I combine them and just make it all one single log. But when I'm adding them, we multiply them. So this is our final answer here. Okay, example 2. What is each logarithm expanded? So we went from condensing them into one, and now we're expanding them into more than one. So let's look at A. So here, they're being divided, and we know division goes with subtraction. So we're going to say log of 4x minus log of y. So here we don't have a base for our log, so our answer is just not going to have a base for the log either. There's one more thing we can do though before we're done, because we still have the 4 that's being multiplied by the x, so we can expand this one step further. So since these are being multiplied, multiply goes with addition. So we're going to expand this to log of 4 plus log of x minus log of y. And this here is our final answer. Now the order is important here, so the order matters. If this y is on the bottom and it's being divided, we have to keep that y as the last thing here. So we can't move this up here. That would not work. So the order matters. Any questions on this one? All right, let's go to example B. So here, they're being divided, and we know division goes with subtraction. So we're going to break this up into log base 9 of x to the 4th power minus log base 9 of 729. Now we still have this x to the 4th power, which we know when we have a power, we can just take this and move it to the front. So we're going to say 4 log of 9 minus log base 9 of 729. So a logarithm with base 10 is called a common logarithm. If no base is written for a logarithm, the base is assumed to be 10. For example, log of 5 is equal to log base 10 of 5. So if there's no base here, then we just assume that that base is 10. This is important because in your calculator, depends on what calculator you have, but most calculators will only do log base 10. They only do common logarithms in the calculator. So calculators only do these. So we need to change logs that are not common logs into common logs, and we can do that by the next slide. So here we have the change of base formula. So for any positive numbers m, b, and c with b not equal to 1 and c not equal to 1, we can take a logarithm that looks like this and change it into this. So this is the change of base formula, and this will help us put logs into our calculator. So if it's asking for an exact value, if we had a log, let's say that was log base 5 of 25, we can change this into log 25 over log of 5. So the big number goes on top, the little number goes on bottom. So what is the value of each expression? So we need to change this with our change of base formula. So we have log of 27, the big one goes on top, over the log of 81. And now we can put both of these into our calculator. So we're going to do the log of 27 in our calculator. Which would give us 1.43136. Now it doesn't matter how many you write down here, but the more numbers that you write down and keep, the more exact your number would be, your final answer would be. So I'm just going to write down 5 decimal places. So now we're going to do the log of 81, which is 1.90848. And now I'm going to divide these two. So I'm going to take 1.43136 divided by 1.90848. And this gives me 0.75. So we can't do this log in the calculator, so we have to change it into the change of base formula here, and then we can put it into the calculator, because now we don't have, our bases are now the common logs. So when we don't have a base, they're common logs, and we can put common logs into our calculator, and we get 0.75. Any questions on this one? All right, let's go to example B. So we're going to do the log of 36 over the log of 5. So if we put the log of 36 into our calculator, we get 1.5563. And then if we do the log of 5, we get 0.69897. And now we're just going to divide these two. It's important that you guys practice doing this in your calculator, because when it comes time for the test, you need to be able to do this in your calculator. A lot of people on the quiz didn't know how to use their calculator for some of the problems, and I could tell you guys haven't practiced. So it's important that you guys practice doing this in your calculator. Okay, so when we do 1.5563 divided by 0.69897, we get 2.23.